JavaScript is one of the most interesting programming languages simply because you can write software in a variety of different ways. We primarily live in an object-oriented world, but we're not bound to that paradigm. We can also take a functional approach, and with UI libraries like React and Svelte, there's actually been a push toward functional programming. Hi, I am Jeremy McPeak, and I would like to spend some time with you to get you started with functional programming with JavaScript. But first, if you are looking to create a professional website or you want to add features to make your website stand out, then head over to CodeCanyon, the marketplace for high-quality JavaScript and PHP components, HTML5 and mobile templates, and so much more. The items at CodeCanyon can help you easily add the functionality and eye-popping visuals that you need to meet your business's goals. You'll find a massive library that contains thousands of JavaScript and PHP components and almost 20,000 HTML and mobile templates. Needless to say, you'll find what you're looking for to take your site to the next level. Now, this is a completely different world compared to object-oriented programming, and it could take a little bit to wrap your head around, but I promise you that by the end of this course, you will understand some important things like first-class functions, immutability, composing functions, currying, and even working with the DOM in a functional way. And you will be able to take this knowledge and use it with more powerful and functionally aware libraries like React and Svelte to write expressive and readable code. So when you're ready, cue up the next video and we will get started. Before we dive into functional programming, let's first of all set up a nice little web-oriented environment. Because when it comes to any type of web development, in this particular case it's JavaScript, I like having a realistic environment. That means having an HTTP server, serving files over HTTP, and all of that wonderful stuff. Because especially if you plan on doing anything with HTTP, like making requests with JavaScript, you need a web environment. So for JavaScript, I like using Node because it's very easy to get up and running very quickly without a whole lot of configuration. So if you don't have it installed already, go to nodejs.org and download the recommended or the LTS version. LTS just stands for long-term support. That means it's going to be supported for a very long time. The installation is very straightforward. Just take the defaults and you will be good to go. So that once you have that done, then you're 75% there. Now, something else that should be pointed out is a code editor. Now, I'm using Visual Studio Code, which is, it's not even arguably, it is the best development environment for JavaScript. So I highly recommend that you use Visual Studio Code. You can, of course, use whatever you want. There are plenty of code editors available. There's Atom, Brackets, Sublime Text, and a whole host of others. Many of them are free, many of them are not free. Visual Studio Code is free. It's also cross-platform, so I highly recommend that. And once you have those things, then you can close your browser, at least temporarily, because we will eventually get back to the browser. But then you will want to open up a command line, and you will want to make a directory for this particular project. I'm going to call this JSFP, and then you will want to cd into that folder, and then type a command, npm init-y. This is going to essentially set up a node project for us. And the -y just sets all of the default values. Otherwise, you would have to go through and set them individually. Then once that's done, just fire up your code editor and we can get started. The first thing I want to do is create a new file called bs-config.js. This is going to be a config file for a package that we are about to install. So go back to the command line, run npm install light-server --save-dev. This is a very simple HTTP server that will, well, it's an HTTP server. There's really nothing a whole lot there, except that it will automatically track changes to our files and it will automatically refresh the page so that we don't have to constantly save a file, go to the browser, press refresh, and so on and so forth. So there's a few things that I want to set here. The first is a property called open. Now this is a JSON file, at least it should be. I named that JS. The file name is bs-config. index.json. So this is a JSON file, so be sure to use JSON syntax. And so the first option is going to be open. We're going to set that to false. Otherwise, it will automatically open up a browser whenever we run the server, and I don't want to do that. The second option is called server, and this is going to be an object that's going to have a property called base directory or base dir, and we're going to set this to /public. So this is telling the server that all of our files are going to be inside of a folder called public, and so it's going to start serving the files inside of that folder. And those are really the only two options. So with that done, you can close that. And then we want to go to this package.json file. This was created whenever we ran that npm init command. You can see that there's this dev dependencies where light server is installed, but we want to come up here to scripts and we want to add a script. We'll just call it start, and all the value for this is going to be simply light server, so that we can get our server up and running by running an npm command called start, and we will do that in a moment. So now we just need to create our folder called public. Let's create a new file inside of there called index.html. Let's give it some HTML and let's put some text in the body just so that we can see that this is going to work. Let's go back to the command line and we will say npm run start. This is going to start up our web server. It's also going to tell us where to go. So we can see that we need to go to localhost at port 3000. So we'll hop back over to the browser, localhost 3000, and there is our file. So our environment is up and running. We are ready to start in the next lesson. Functions are very important to functional programming. I mean, that kind of goes without saying, doesn't it? But in JavaScript, functions are what are called first-class objects. And you might have heard that term, but not really known what it means. Well, it's very important, actually, because you can't really have functional programming without functions being a central part of the language, which is kind of what first-class means. I mean, it doesn't exactly, but let's do this. Let's create a new file called firstclass.js, and let's define a function. Let's just call it add. We will accept an x and y for parameters, and then we will simply return x and y. Very simple function, but by just defining this function, we have created a function object called add. So we have a type of data called function, just like we have string or Boolean or number, we have function. And since we have a data type called function, that means that we create these function objects and we can use them just like any other type of object in JavaScript. So that actually means that we can create a function and assign it to a variable. So you might see code that looks like this, to where a function expression is being assigned to a variable. Now, there is a slight difference between how the JavaScript engine actually interprets these two functions whenever it's loading it. But once it loads it, they are essentially identical. We end up with a function called add that accepts two values, and it performs a computation on those values. Now, of course, we have two completely different function objects. You know, this one that's defined with a declaration is completely different from this one that we defined with an expression. But that's just because we created two function objects. That has really nothing to do with how they are created. So the idea that we can create a function and assign it to a variable actually opens up a whole lot of doors that we normally wouldn't be able to do in some other languages. Like, for example, we can pass a function as an argument to another function. Let's say that we wanted to set an event listener for the click event on the document object. Well, the first thing that we pass to add event listener is the type of event that we want to listen for. The second thing is a function. We are passing a function to another function. And if functions were not first-class objects in JavaScript, this probably wouldn't be possible. Well, it might be possible, but not to the extent that it is. But if we can pass a function to another function, that kind of also means that we can return a function from another function. Like for example, let's write a function called greet. And there are really two parts to a greeting. There's the salutation, and then there's the name of the person that you're greeting. So the salutation could be hello, hi, howdy, or if you're from another part of the world, there's several different ways that you can say hello to somebody. So in this particular case, it would look very simple in that we would have our salutation, and then we would have the name after the salutation. And that's all well and good. We've written functions like this all the time. But what if we wanted to write a more specialized function for greeting someone, so that we would have like a function called howdy, and then we would pass in the name Jim. And so that would output howdy Jim, or we would have hello and pass in Jim, and that would be hello Jim. Well, we can write that in a couple of different ways, but really the best way of doing that would be to write a function that would be used for essentially building another function, so that our greet function would actually accept the salutation, and then this function would return another function that accepted the name. And then, of course, inside of this inner function, we would return the salutation and the name. And I butchered that. There we go. So it required a little bit of extra code, but what this means is we could actually do something like this. We could create our howdy function by calling greet and passing in howdy. And then all we would have to do is say howdy, passing in Jim, or Bob, or whatever name that we wanted. And then if we wanted a function for using hello, we would essentially do the same thing, so that we would pass in hello for the salutation, and then we could use hello for the same purpose. So what we end up with is actually a good way of reusing code. If we were going to write this using object-oriented principles, we would have a greeter class that would have a property for the salutation, and then it would have a method to actually perform the greeting. So the first thing that I want you to do is to start thinking of functions in terms of being an object. Yes, it is something that we can execute, but more importantly, it's something that we can store within a variable, we can pass it to other functions, we can even return it from other functions. Because all of the ideas and concepts that go into functional programming all revolve around that. One of the ideas behind functional programming is the concept of declarative programming. Now, this is actually a concept that has been permeating the JavaScript community for a very long time. It might not necessarily be in terms of functional programming, but if you look at the UI frameworks like Vue or React or Svelte, they all encourage you to build user interfaces using a declarative style of programming. Like, for example, this is Vue, and this is the template for a very simple Vue component. But if you look, it looks mostly like HTML, but if you look a little closer, you can see that there is some kind of declaration going on, and this actually sets up the click event handler for the button, and this is the JavaScript code that will execute. Now, of course, this is a very simple example, and doing something more complex might require you to write a function that handles the click event. But the idea of setting up the event or outputting information is all part of a declarative style of programming. Well, with functional programming, it's not very different. So let's look at this. So let's create a new file. Let's call it declarative.js. And let's create an array. We'll just call it numbers. And it doesn't matter what the values inside of this array are. I'm just going to use some simple values. Now, in typical JavaScript code, we would take an imperative approach. That is essentially telling the computer what to do. Here are the steps that you need to go through, and here is the exact way that you're going to do it. So we might use a for loop here, and we would say, okay, here's your counter. You're going to count each item within this array, and you're going to do so for as long as the counter is less than the length of this array. And you're also going to increment. And then from here on out, you're going to access each element using the index and so on and so forth. That is an imperative style of programming. Well, with functional programming, we typically don't do something like that. We rely upon functions to do it for us. So in our particular case, we have an array, and an array has a for each method. And this accepts a function that will execute for every item in the array. So if we wanted to display each item in the console, then all we would have to do is pass a function that accepts the item and then write that to the console. And so the idea behind declarative programming is so that if you're new to a code base, you can get an understanding of what's going on far quicker than if you are dealing with imperative code, because imperative code gets bogged down in the details, like our for loop, whereas declarative code is much cleaner and it reads much like how we would say it. Although we can actually improve upon this. Let's say that we had a function called output that accepts the item and it simply writes that item to the console. Well, then we could just use this function instead of an anonymous function. And that makes it far more easier to understand what's going on. And then we could take it a step further. We might have a for each function that we would then pass in our callback, and then we would pass in the array of numbers so that this even reads much better. For each item, we're going to output these numbers. And so when it comes to functional programming, we tend to stay away from these control structures, which are basically every type of loop. So for, while, do, while, and so on. We also tend to stay away from if statements or if else. We might also stay away from switch statements. Instead of if else, we might use a ternary so that if we needed to make a decision, it would be a very simple operation. So it might look something like this. If something is true, then we have this value. Otherwise, it's that value. So the idea is that we have this very concise, very easy to read code broken up into small functions that we would then build larger applications with. Now, with saying that, there are some concepts in functional programming that, well, it takes a little bit to wrap your head around. However, once you have the concepts down, understanding an application that's written using a functional approach is much easier to understand. And it's all due to declarative programming. There are two types of functions in functional programming. The first is a pure function, and almost by definition, the second is an impure function. So we're going to look at examples for both of these in this lesson. So let's create a new file. Let's call it pure.js. And let's first of all talk about a pure function. This is what we want to strive to write because they are easy to test. They are also easy to predict because they always return the same result with the same input. So here are some rules for a pure function. It can only work on the data that is passed to it. It cannot work on any external data. It has to solely depend upon its input, which in this particular case are two parameters. Now, it doesn't necessarily have to do anything with those two parameters, but it has to return the same result for the same input. So if we call add, we pass in 1 and 2, the result is 3. If we call add again, pass in 1 and 2, the result is, of course, 3. If we call add, pass in 1 and 2, you get the idea. No matter what we pass to add, it is going to give us the sum of those numbers, and if we pass those same numbers, we are going to get the same result. This is a pure function. Now, let's look at another function. We'll call this add2. It's going to accept x and y, and it's going to return the result of adding those two things together. But it's also going to write the result to the console. Now, in this particular case, this is not a pure function. This is an impure function. First of all, because it relies upon external data or external information. The console is external. It was not passed to the function itself. It also has a side effect. It writes something to the console. Now, that might not sound like a deal breaker, but it is when it comes in terms of a pure and impure function. There is a side effect to calling add to. It might give us the same results if we pass in the same information, but it is mutating the state of our application by writing something to the console. So let's add a comment here. This is external, and it produces an observable side effect. So then what would be considered an observable side effect? Well, quite a bit, and just about anything useful that we would need to do within an application, such as HTTP requests, reading or writing to local storage, querying or manipulating the DOM, or even just simply changing state. All of that is considered an observable side effect, and it makes our functions impure. And if you're like me, you take the term impure with a negative connotation. I mean, who wants to be impure? But it's not really about that. Yes, we want to write pure functions because pure functions are consistent, and therefore they are easy to test and predict. So when it comes to writing our programs, yes, we want to write pure functions, and we want to write as many pure functions as possible. But in order to do anything meaningful, we will have to write impure functions. Before we start our project, I want to discuss a concept called immutability, because it's very important in functional programming, and it ties in very well with the pure functions that we talked about in the previous lesson. So let's create a new file called immutability. And if you're not familiar with that term, it's very simple. It basically means that it cannot be changed. If something is immutable, it means it cannot be mutated. Thus, it is consistent, it's safe, and that sounds a whole lot like the pure functions that we talked about in the previous lesson. If something is consistent, it is predictable, and therefore it is also testable. So let's start with just a normal variable. We'll have salutation, and we will assign that to hello, and everything's great. Our application is saying hi to everyone. Hi, Jim. Hi, Bob. Hi, you, and you, and you. And then later on, it might be months down the road, there's an update to the application, and for some reason, somebody mistakenly set salutation to bye. And so suddenly our application is now saying bye to Jim and Bob and everybody else, and that's kind of ominous coming from a computer. And so because salutation was mutable, since it could be mutated, it was mutated. It was an accident, but the fact remains that it was mutated, and therefore we ended up with an inconsistent or an unpredictable result. So to fix that particular problem, we would just create the salutation variable as a constant using the const keyword. And now salutation cannot be changed. It is immutable. Now, that's great for simple values like strings or numbers or booleans, but let's talk about an object. Let's create a person object that has a first name called Jim. So the const keyword is great in that it protects the variable itself, but only the variable. So we can't come back to person and assign it a new value. We can't set it to an empty object. We can't set it to null. We can't do anything with it because it is constant. However, it does not make the object itself constant. So we can come in and still mutate the person object. We can give it a last name of Doe. So to fix this particular problem, there is a method called object freeze. This creates an object that is frozen. It cannot be mutated. So now we have a constant variable called person. It contains a frozen object that has a first name property, and so we cannot add a last name property later on. We can use object freeze with just about everything, but it only makes sense for objects and arrays. So let's look at an array. I'm going to create one that starts with 0, 1, 2, 3, 4, 5. Let's change this to indexes. The idea here is that the values for these elements also match their indexes. So let's say that we want to write a function that is going to manipulate or change the value of this array. So let's just call it add element, and it's going to accept an array. Now, since this is a frozen object, we cannot use push and add in the next item in the array. In fact, we wouldn't want to do that because we don't want to mutate data. Mutating data is unpredictable. It is inconsistent, and we want to avoid that as much as possible. For one, it would not only manipulate the array that was passed to it, but that manipulation would also affect anything else that array is being used for. So it could be catastrophic to our entire application. So we want to work with immutable objects, so we don't want to use push. And hopefully the array would be passed as a frozen array. But if not, we want to still stay away from any manipulative methods. So then the question becomes, how do we manipulate this array? How do we add the next item to it? And that's very simple, actually. We just create a new array. Now, I know that sounds a little over the top because it's a whole lot easier and it's much more efficient to just manipulate the things inside of the array that we need to. I mean, it's a whole lot simpler to just push in that new item. It's much more efficient. But, and I feel like I'm a broken record here, but manipulating it is inconsistency. It's introducing unpredictability. So instead we just create a new array and return that. So we would do that like this. We would still use object freeze, and we would spread out the array that was given to us, and then we would just add in the next item. So we could call add element. We could pass in indexes that would return a new array that has 7 items in it. And then we could pass the result of that to another call of add element, and that would produce another array that had 8 elements in it. Now, I fully understand that this looks impractical, and yeah, this particular example is. However, in our project, you will see immutability used in a meaningful way. Our project is going to be relatively simple, especially if we were just taking a normal JavaScript approach, and it would be dead simple if we were using a UI library. But since we are taking a functional approach, it's going to require us to rethink, because functional programming is a completely different paradigm than what we are used to, which is object-oriented, and the DOM is nothing but object-oriented. So when it comes to working with the DOM, we really have to think about how we want to do that using functions, because it's just not something that we are used to. So our project is simple. We will enter a message into the text box, click on the Add Message button, and then it will display a list of those messages. I mean, it's nothing really difficult, but since we are using functional programming, then we just need to think about these things. And I also want to point out that I've taken the liberty of doing some cleaning and some setup. So all of the JavaScript files that we have created thus far, I put inside of a folder called Scratch, inside of a JS folder, just to still have those there, but they're kind of out of the way. I've gone ahead and added the markup, which isn't spectacular. I mean, there's 3 elements we need to be aware of: the message text, the message button, and then the message list, and that's it. I also created the list.js file that's going to contain the majority of our JavaScript. And of course, all of this is already available in the code download. Just look for a folder that says project start, and this exact setup is there. Now, I should also point out that if we did want to use a UI library, React and Svelte are very good for functional programming. And I thought about taking that approach, but it just makes it way too easy. So this way we get to some practice and we get to learn some concepts simply because we are working with the raw DOM. Now, Vue.js is a wonderful library, but it isn't quite there as far as the features, or I should say the functional features that are already present in React and Svelte. But it's getting there. Now, there are 2 things that we need to tackle here. First of all is handling the click event on our button. The second is generating content. And our message list is going to be a div element that contains multiple div elements that will have the message in them. So let's start with that. Let's generate some content first, because if we can't generate content, well, then we don't need to be doing this at all. And so let's first of all think about how we might approach this with objects. So we of course have the built-in DOM API, which we will definitely have to use to create our elements and all of that stuff. But I like to have a wrapper API, something that makes it a whole lot easier to create and work with the objects that I need to. So if I were taking an object-oriented approach, I would have something like this. I would have a constructor function called element that I could pass in the type of element that I wanted to create. And this would be a wrapper object. It would wrap around the DOM object. And I would have methods that I would use that would manipulate that DOM object. So if I wanted to add a class, all I would have to do is call a method called addClass, and then pass in the CSS class that I would want. But then I would want this addClass method to return this element object that I'm working with, because then I could chain multiple method calls, making my code a lot easier to read. So in this case, I would add in another class. And then if I wanted to append some content, I might have an append method. And then I would pass in another wrapper object that would wrap around some other kind of DOM node, like a text node. I would specify the content to display, and that would build my element. And really, there's nothing new here. We've been doing this for a very long time. Now, in functional programming, we don't really work with methods or anything like that. We work with functions, but we have the logical equivalent in what's called composition. We can compose functions to work with the same data, so that one function is called after another function that's called after another function, so that it ultimately looks like this. We would start with our addClass, and of course we would pass in the class name and then the element object. This addClass would return an element object so that we could use that to pass to another call to addClass. And since this returns an element object, we could use that to pass to our append function so that it would look something like this. And yes, this looks horrible. I mean, I don't know about you, but my eyes start to glaze over. There's a lot of commas, there's a lot of parentheses, and trying to figure out how all of this works is, well, it can be a little challenging. So instead, in functional programming, when we want to compose a lot of functions together, we would use a function called compose. And the purpose of this function is to create another function that we would pass our element object to. And behind the scenes, the compose function will take this element object, it will pass it to the addClass function for the CSS class. It will then pass it to the next addClass function, and then it would pass it to append. So it wouldn't necessarily look exactly like this, but this is the general idea. Now, as far as reading this is concerned, it looks like it's being done in reverse order. So a composition actually reads from right to left. We start with the element, we pass it to addClass, we pass it to addClass again, and then we pass it to append. But there's another type of composition called pipe. And it's essentially the same thing, but it's in a more logical approach, if you ask me, at least when it comes to reading is concerned. So once again, we would have our element object, but it would be passed like this. We would start with the addClass, followed by addClass, followed by append. And so in this project, we're going to be using both of these compositions. We will use pipe in one place, we will use compose in another, just so that you can see how they are used. And so now that you know how we are going to approach that particular problem, we will implement it in the next lesson. In the previous lesson, we talked about our functional approach for creating DOM objects, and we talked about the idea of composition. And there are two types. There's the compose, which reads from right to left, which looks weird. Then there's the pipe, which reads from left to right. Now, of course, compose and pipe don't exist in JavaScript. It would be nice if they did, but they don't, so we have to write them ourselves. Or we could rely upon a third party to give us that capability. And that's what we are going to do so that we don't get off into the weeds of implementing these things. I just want to use these things. Now, there are many libraries that give us functional utilities, but Ramda is one that is built specifically for functional programming. There is Lodash, which is also very popular, and there is a functional library for Lodash, but it was kind of tacked on at the end of things. That doesn't necessarily mean that it's bad. It's not. People use it all the time. But Ramda was designed for functional programming, so yeah, we'll use it. And there's a lot of functions that we can use to make our lives a whole lot easier. They implement a lot, and all you have to do is just do a search for them. So if you wanted to look at the pipe documentation, it's right there. If you wanted to look at compose, it's right there as well. So this is what we are going to do. And I'm going to pull this in via a CDN. And we'll just copy that and paste it into our HTML file. And I'm going to put it right above where the list.js definition is. So there we go. We have Ramda. And in order to use these functions, all we need to do is use the R object. And then we call these as methods. So we would have compose or pipe as well. So let's first of all write a function that we can use to create any HTML element. And for this, I'm going to use the new lambda syntax or arrow functions because this is a very simple function and we can write it all on one line. Let's call this elem because it's short and sweet. It's also kind of clear as to what this is going to do. We'll have our tag name, and then we will simply just return the result of calling create element, passing in the tag, and there we go. So we should be able to just create our element, calling the elem function, passing in div for a div element, and then later on we can append that to the body to make sure that that actually worked. So let's go ahead and have that set up. Let's also get rid of all of this code that does not work so that we don't run into any issues there. Okay, so we want to build this div element and we're going to use the compose method here. So we will call compose. Now compose is going to return a function and we want to pass whatever it is that we want to work with. So in this particular case, that's going to be our div element. So it's going to take this div element and it's going to pass it to all of the functions that we specify whenever we call compose. And whenever it's done, it's going to return whatever the final function returns, which will be our div element, because we will make sure that all of our little builder functions will return an element. So we want to pass function objects to compose. So that means we would have like a function called add class. And this will need to return another function. In fact, we looked at something like this, didn't we? Let's go and look at our Scratch. If we look at first class, maybe, yes. Whenever we created this greet function, it was kind of a two-step process. Greet was just a generic function, something to set up or partially apply, so that if we wanted to create a specialized function for saying howdy, we called greet, we passed in howdy, that gave us a function that we could then use to say howdy all of the time. We could do the same thing for hello. So we can use this same concept to create these types of functions so that add class will actually accept the class name, and this will return a function that accepts the element. And then element will be used to set the class list. We'll call add, pass in class name, and then we will return the element. So like that. We're actually going to take a different approach here, but I want to make this work. So we are going to call add class. We're going to add the BG light class just so that we could see something other than a white background. Let's also add some padding as well. And let's do P-2. That might be too small, but we will see. So if everything is written okay, this should work. If we look at elements, and here, yes, we have a div element with the class of P2 and BGLite. Now, notice though the order in which these classes appear. P2 is first, BGLite is last. That is different than how we typed it, but remember that we are composing here. This goes in reverse order. It reads from right to left. So it's calling this add class with the class of P2 first, then it's taking the result of that function, passing it to the next add class, which is then BGLite. So this is working. This is great. But this is rather tedious because we also need a function for appending children. And I don't know about you, I don't want to have to keep writing a function that's going to return a function. Instead, I just want to write a function that has the node and has the element so that we can just straight up and use those objects. So that we would append child, we would pass in node, and then return element. And we can actually do that. That uses a concept called currying, and we will look at that in the next lesson. In the previous lesson, we finally started implementing our code for generating DOM objects, and we are off to a very good start. We can create our HTML elements. We can also set CSS classes to them using a very good methodology of function composition. The only thing I don't like is how we had to implement add class, because the compose function needs functions in order to work. It's going to call those functions and pass in the appropriate data. So we need to create a more specialized function so that we could specify the CSS class that we wanted to apply to the element. Then we had a function that actually performed the work. And while this approach obviously works, I don't like it because I just want to write a normal function, one that accepts the information that we need, does the work that we need for it to do, and nothing else. And we can actually do this with a process called currying. And this might take a little bit of time to wrap your head around. It certainly did for me. But really, it's very simple. We will use Ramda to curry our function. And this is going to create one of those specialized functions. Just like what we did with that greet functions, we could curry this if we wanted to, so that our greet would actually look, halfway normal. So we'd have the salutation, which I just misspelled, and then the first name, and then we would do the actual work there. And the great thing about currying is that it creates a function for essentially every parameter. So if we needed to, we could create specialized functions based upon any of the parameters that we provide. So let's first of all assign this to append. And now we have a function that we can pass in the node that we want to append to. We could also pass in the element if we wanted. But we could create a new function by just passing in node. Then we could pass in the element to append that node to. And it might be a little more clear if we have something that's a little bit easier to understand. Let's call this a TTR, short for attribute. And so we will curry this function. It's going to have the attribute name, and it's going to have the attribute value, then it's going to have the element that we want to set this attribute on. So that the code is going to be very simple. We will set attribute. We will have the attribute name as the first argument. We will set that to the attribute value, and then we will simply return element. And so this gives us a function that we could do several things with. If we know that we wanted to set an attribute called data ID, so we can have data ID. Or rather, let's do this. Set data ID equals. We would call the attribute function. Our attribute name would be data ID. And then this would give us another function that we could call to set data ID to the value that we needed. And then we could also supply the element. Or if we needed to supply the same data ID to multiple elements, which I don't know why we would need to, but we could do this. So that then we could call set1, pass in the element, that would then set the data ID attribute equal to 1 on the provided element. So it's a very, very powerful feature, and it allows us to write just normal functions without having to worry about returning other functions. So we can rewrite this add class like this. We will call curry, and then we will pass in just a normal function that accepts the class name and the element. So that inside of the function, we just set the class list to include that new class, and then we return the element. Now, returning element is very important here. If we did not return the element, we would not be able to use that in our composition, because compose is going to take our div element, it's going to pass it to this first add class with p-2, then it's going to take the result of that function, pass it to this add class, then it's going to take that result, pass it to the attribute function so that we can set data message equal to, well, whatever we want. And then we can append some data to it. Like, for example, let's have a text node that will simply have our message. And of course, we need to write that text function. So let's quickly do that. All we are going to do is create a text node. We will pass in the provided content, and there we go. Now, of course, in order for this to work, we need to move this after these definitions. But when that's done, we should be able to go to the browser, and there we go. We have our div element. The p2 and bg-lite classes are applied. The data-message attribute is also applied, and then our content. So everything is right there. And we have nice, clean code that is relatively easy to understand once you understand how curry and compose work. And so now let's wrap this in a function called message, where we will accept the content and we will simply return the result of this composition. And of course, let's change the value of this data-message. Let's use our content value. We also want to pass content to our text node. So that now, if we wanted to, we could call message, and then this is some text so that we can see that in the browser. There is our element. If we look in the markup, we have, once again, CSS classes, our attribute value, and then of course our content. So now that we have a way of generating content and adding that to our document, we need to get some of the nuts and bolts working, and we will get started with that in the next lesson. I know I said this at the beginning of the previous lesson, but we really are off to a very good start. We can easily create content using code that's easy to read and follow, and that is a huge, huge thing. So that now we just need to start focusing on the application itself and making sure that all of the nuts and bolts are in place so that whenever we finally add in that click event listener, that things are just going to, well, click into place. But first, I want to organize our code a little bit because we have quite a few functions, and these are more helper functions than anything else. Of course, they are being used by the application, but I want to break those out into a separate file so that we have all of our helper functions, which really, they're not really helper functions. It's more DOM stuff, but we'll just call it helper stuff. And then we'll have our main application code inside of list.js. And of course, we do need to reference helpers inside of our HTML file. But once that's done, let's make sure everything works. Looks like it does. All right, so we need some way of starting our application. So let's have a function called app, and we will call app to start the whole thing. Now, in order for our application to work, we need some data to work with. So we need some initial state. So really what we could do is pass in an array that will For right now, contain a couple of items so that we can actually see what it's going to look like in the browser, and then we can add in all of the event stuff. So this is the first message, then we'll have a second message. So that's going to be our initial state. And then we also need the output. Where do we want this stuff to go? And I guess we could just get the element object itself, because we have append and all of those functions available for us. So we could just provide the element of where to put our messages and then let the application do all of that work. So let's write a helper function called getElem, and we need the ID, and this is simply going to return getElement by ID, but it will give us a much shorter way of doing that. So we will call getElem, we will pass in not that, what was it, message list. Guess we'll look at the HTML and see, yes, message list. So of course we need to add those parameters here. So we will have our state, and then we will have our output. So our state is nothing more than an array, and we want to take that array and we want to create these div elements for each of those messages. So since we have an array, we can use the map method, and then we can simply work with each content and each index. And we want to create a message, passing in the content and the index. The reason why I'm going to use the index, because this would give us a perfect thing to use for this attribute. So let's change the attribute name to index. Then we will use index as the value. So that's the idea. But we also want to build these messages and just make it easy to provide that to the output. So what we could do is essentially return append. We can prime up some calls to append. We could pass in the message, and yeah, that should work. So let's do this. We will have const, we'll call this append functions, and then we will use pipe in this case. The reason why we're going to use pipe is because remember that pipe reads from left to right, as opposed to compose, which is right to left. Well, our data is coming in as left to right, so it makes sense to use pipe in this case. So we're going to use pipe. We will spread out the append functions, and of course we need to supply the output for those append functions. That should work. So there we go. That worked. It's time to buy a lottery ticket because that worked the first time. And that's wonderful. But let's do this. Let's add some more padding. Let's also change the background color. I'm drawing a blank as to what is available. Let's see what primary looks like. No. I guess let's go with warning. That's going to look ugly, but we can at least see it. Okay, so that's working. That's great. However, you know what? Let's look at our elements. And here's our message list, and we are appending each div element one at a time, because that is essentially what we've done. We have iterated over our state, and we are appending each one of these div elements individually. It doesn't look like it, but that's essentially what's happening. So if we want to be more efficient, what we need to do is before we append anything to the document, we need to append these individual div elements to a container div so that we just append once and that's it. So let's create a function that we'll just call view. And this is going to work with the state. We don't need the output here. We are going to be doing a lot of what we've done here because we still want to build these append functions. We still want to pipe everything. But instead of going to output, what we will do is create a new div element. That will be our container. We can return there so that then all we really need to do is call append. We will call view, passing in state, and then output. So let's take a look at what that looks like. We have the same result, at least visually in the browser, but if we look at the markup, we have our message list followed by our div element, that is our container, and then our individual messages. So that's great. Now that we know that that works, let's get rid of our messages here. And let's go back. Let's look at the console. We do get an error. Pipe requires at least one argument. Okay, so here's what we could do. We could create our element, and then we can check to see if we have anything as far as state is concerned. And if so, then we will go through this whole stuff. If not, then we will just return our element that we created. So let's first of all change this. Let's use an arrow function here because I think that that might be a little bit easier to read because there's no curly braces, there's no return statement, there's less parentheses, and we'll try to do this all in line. It might look ugly, but we'll just have to see. So we're not going to have this append functions variable. Instead, we're just going to inline that, and that looks halfway decent. Okay, that'll be fine. So now what we'll do is we will check the state's length. If it's greater than 0, then we will go through all of this stuff. But if it's not, then we will just simply return the element. That way we only call pipe if we have data to work with. That error goes away and we're good to go. So in the next lesson, we can start focusing on our events. Really, we just need one. We need the click event, but we also need to grab the information from the input element so that we can add that to the state. Our application can display messages, and that is a huge thing. So now we just need to focus on handling the click event so that we can grab the text from the input and adding that to our messages, so modifying our state. So let's just jump right in. The first thing that comes to mind is we need a function for getting the text of our text box. So let's just call this getText. We don't need any parameters for this function. And we will use getElement. We will get the element with, I believe it's called message text, and then we will get the value, and that will give us that value. So that then we just need to handle the click event. And we could do it like this. Let's call this on, and let's curry this because that would be very powerful, especially when working with events. We need the event type, we need the element that we are working with, and then the callback function. And so we will just say elements, get element by ID. I mean, I've written tons of functions just like this to make it a little bit easier to set up event listeners. So we have our event type, we have our function, there we go. And it is curried, so we could do something like this. Let's go back to our code and let's create a button click. This is of course going to be a function, but this will give us the ability to go ahead and set up an event listener for the click event for our button. And that was message button, I think. Let's look at the markup and let's make sure. Yes, message button. So that then all we need to do is supply the callback function, and then we're pretty much good to go there. And, you know, we could pass this here. In fact, I guess we could go ahead and do that. So let's say button click. We're going to pass that in. And let's call this dispatch, for the lack of a better word, I guess. I don't know. If something else happens, then or something else makes sense, then we'll go with that route. So let's go ahead and set this up so that we will have our event listener. So we of course want to get the new text, so we will call that get text function, although we should probably pass that as well to our app, but we'll be lazy and leave that alone. And then this is where the magic is going to happen. We are going to create a new state, but we want to take our existing state and we want to spread that out. And then we are going to add in our new text right there. So that now that we have new state, we can call app again. We can pass in our new state, pass in the output, pass in dispatch, and there we go. That should work. Let's find out. Well, immediately we get something wrong. Get element by ID is not a function. Let's go here. And it's probably an issue with the autocomplete. I'm not seeing it. I guess I should have paid more attention to where this was. Helpers line 8. So let's take a look here. And no, that was just me typing the very wrong thing. So event listener, there we go. All right, so let's type in a message. Let's click on add message and boom, there we go. So the first thing I see is that we should probably clear out this message here, but let's add another message. Let's add message, and it worked. But yeah, what we're doing here is appending. What we need to do is clear out our output element so that we can add in the new. So let's add another helper here. Let's call this clear. And we don't need to curry this because we only have one argument here. So let's do this. We'll set inner HTML to an empty string, and then we will return element. So now we need to use clear whenever we append to the output. So we can compose this. Let's use our compose. We will first of all have append first because we want to clear first. And remember, we have to do this in reverse order. So we are going to clear, but no, if we want this to be consistent, we have called every single function and we kind of need to clear or call clear like that. So yeah, I guess we need to curry this. So we will curry the clear function. So that will be consistent. And then we will append, and this is of course going to go to output. So there we go. We do need to remove output there because, well, we are doing it now with compose. All right, so with that done, let's go back. Let's enter something. Let's enter something else. Okay, so that is working now. That is behaving. So now we want to clear out the text box. So let's write another function. Instead of getText, we will setText. And we might just want to say clearText. But I guess we should do setText because that is more correct. Then we will set value to value. That should work so that inside of our click event handler, which is now called dispatch, we will get the text, we will set the new state, we will then set text to be an empty string. All right, so let's go back and we type in a message that cleared out. That's great. But now we have something else. And I already know what the problem is because I thought that this would be an issue. Whenever we click on their button, we are calling app. So we are essentially kickstarting our application again, which is setting up the click event listener again. Because, you know, at this point in time, we are adding that callback function that is completing the whole process of setting up the event listener. So we are setting up multiple event listeners for the same element over and over and over again. They are interacting with one another and they're giving us this wonderful experience. So here's what we can do. Let's go to our helpers. And we, of course, still want to set the event listener, but let's return a function here. And this is going to give us a very easy way of removing the event listener that was set for this call to on. So we just need to pass in our event type. We need to pass in the function that was provided. And so now we can do this. Let's go back to our app. we can say that this is going to be called stop. So that whenever we click on the button, the first thing we will do is call stop. That's going to remove the event listener for the button. Then we will get the text. We will set the new state. We will set the text. We will call app once again, which is going to set up the event listener once again. Then whenever we click the button, we stop or remove that event listener, so on and so forth. It's a little bit tedious, but it's going to work now. So if we type in different messages, we can now finally see the messages and everything is working okay. One of the beautiful things about JavaScript is its flexibility. There are many different ways that we can write an application, using functional programming or object-oriented programming, and there's no hard and fast rule that says that we have to stick to one of those. The language allows us flexibility. And so it does make sense to kind of blend our applications into these different paradigms. Now, there are people that have hard and fast rules that say, no, you shouldn't do that. And ultimately, it's up to us or to you to make the decision of what makes sense to you. Now, Ramda has a method called map, which is what we are going to be looking at in this lesson. Not necessarily from Ramda, but just the built-in map method on an array, because we've used it right here on line 28. And when I wrote this code, I just wrote it. There wasn't really any explanation as to what map is actually doing. So if you don't have any experience or if you aren't familiar with it, then it could be a little confusing. And really, it's very simple. It is transforming one array into another array. And we're going to spend some time in this lesson talking just strictly about map, because it's one of those things that is extremely useful, not just in functional programming where it is highly used, but it is also very useful for just programming in general. So let's start by creating a new file inside of the JS folder. We'll just call it map.js. And we will start here with just a simple explanation, and then we will just dive right in and use it within our application. So the map method allows us to transform the elements in an array and store the transformations in another array. So it doesn't modify the existing array. So let's start with something simple. We'll have an array of numbers, 1, 2, 3, 4, 5. And let's say that we want to transform this array so that it contains 2, 4, 6, 8, and 10. Now we could do that with a for loop. That's very easy to do, but the map method makes our code a lot cleaner. So we're going to have an array of doubled numbers, and we're going to take the numbers that we have. We'll call the map method, and then we pass in a callback function that is going to be used for every element in the array. And this callback function has 3 arguments. The first is the current element that we are working with. Now, I typically use the type of data that I'm working with as this parameter name. So instead of current element, I would use something like number or num or something along those lines. But that's just my personal preference. I'm just going to call it number. The second is the index of the current element, and that's index there. And then finally, we have the array that we are currently working with. So we have all of the information that we need in order to work with the contents of our numbers array. And there are times when you will use 2 of these parameters. There's times when you will use all 3. More often than not, however, you're just going to use the first because you primarily want to work with the data itself and nothing more. So all we need to do here is simply return the number multiplied by 2. And that's it. Whatever return value our callback function is going to return is going to be placed inside of the new array. So this is going to give us a new array that is 2, 4, 6, 8, and 10. And that is so much cleaner than writing a for loop or even a for in or using the for each method. Now, where I personally find the map method very interesting is when we have more complex data like an object, and then we transform that into something completely different like an HTML element, which is kind of exactly what we did already inside of list.js. However, what we're going to do is essentially redo this again, but with some explanation now. So I'm going to take the contents of list.js and save that as map.js. Let's also copy index.html and let's rename that copy to map. Now we do need to modify this HTML so that we are going to be using map.js instead of list.js. But inside of the browser right now, we should have the same functionality. Now we're going to get rid of that functionality because we are just going to work with hard-coded data. Like for example, let me go ahead and paste that in. So instead of just having an empty array as our data, we will have an array of people with first names, last names, and their ages. We're not going to work with their ages in this lesson, but we will in the next. So I'm going to get rid of all of the functionality. So we don't need our button click. We don't need to dispatch in the app. And as far as the HTML is concerned, we don't need all of that plumbing. We just need our message list because that is where we are going to display the people. Now, one of the things that we want to do is display the full name of each individual person. So let's go ahead and let's write a function called full name. We will pass in the object representing that person, and I'm just going to call that the person object. And we can go ahead and destructure this so that we have the first name and last name easily available, so that then we just need to return those two values in a single string. So very simple and straightforward as far as this is concerned. So we have this function, and let's look at our view because that is essentially where everything is being built and then displayed. So we can see that we have our states. We're using the map method to transform that state into what are essentially HTML elements. And we will essentially do the same thing, but I want this to look just a little bit cleaner, a little bit less confusing, because that is a little confusing. And we already have this function for building an element. So what I want to do then is essentially pass in a function that we can call build person. And that is what this message function is going to be. So we're going to pass in this build person, which is going to take our array of person objects and transform it into an array of HTML elements that contains information about that person. So let's go over the build person function. We already know what most of this does, but let's make a few changes. Like for example, let's change the background to BG secondary, but let's also add another class that's going to change the foreground color. So we'll just have text white there. We can still use the index. And as far as the content is concerned, we want to call our first name so that we can then pass in the person object that we are working with. And the beauty about this approach is that our build person function already has the parameter list needed as a callback for the map method. I mean, if we wanted to, we can include the array here and we could work with the array itself. We don't need to, but you could see that that option is there. So that by the end of the map method doing its job, we're going to have an array of HTML elements that contains the information about the person. So then all we have to do is append each one of those elements to our div element that we create inside of the view function, so that then we could return that and everything should work just fine. The question then becomes, how do we do that? Well, one of the ways that we could is to simply use for each. Now, for each accepts a callback function that's going to work with each individual person element. So let's use that person element. And we could do something like this. We have that append function. So we could append the person element to the div element that we created. That would go ahead and append all of those elements and everything would be fine. But wouldn't it be cool if we could just do something like this? Let's comment this out just so that we can see it for comparison. So that we would still call for each, but it would be nice if we could just call append there. so that it would automatically append the person element that we are working with inside of our array to the div element that we created on line 13. Now, we can't do that. However, we can do this. We are going to create a new function, and we are going to essentially flip the append function. What this is going to do is flip the parameters of the append function, so that if we look at that, right now we have the child node as the first argument, and then the parent element as the second. Well, flip is going to flip that so that the parent element is the first argument, and then the node that we want to append to it will be the second. And so we can prime this up by just simply passing in our parent element, so that then we can use add as the callback for each. And then this will give us what we want, so that if we save this and go to the browser, we see our list of people. We have the HTML elements with the appropriate styling, and then of course the names, Jane Doe, John Doe, and John Smith. So map is a very, very powerful operation, and it has so many uses. But basically, if you ever find yourself with an array of data that you need to transform into another type of data, well then map is what you want to use. In the previous lesson, we looked at map and how useful and powerful it is to transform the elements inside of an array into something else that is stored inside of another array. In this lesson, we are going to look at something that is just as powerful, just as useful, except that it's more for filtering out certain elements within an array. And just like map, it doesn't modify the array that we are working with. Instead, it creates a new array that contains just the elements that we want. So let's start by copying the map files, and then we will simply just rename those to filter.js and then filter.html. But of course, inside of the HTML file, we do need to change it so that it is using filter.js. And let's very briefly go over the theory, and then we will implement using filter inside of our application. So we'll start with our numbers array, and let's just have 1, 2, 3, 4, and 5. And let's say that we want to filter out anything that is not an even number. Now, we could easily do that with anything that's going to iterate over the array. So a for loop, we could use for each to do the same kind of thing. But those types of approaches typically show us how to actually do that. And when it comes to especially functional programming, we want to step away from that. We want a more declarative approach, something that says that this is what we are doing as opposed to this is how we do it. So the filter method for the array object will allow us to do that. So let's create a new variable called even, and we will use the filter method on our array. Now, the filter method accepts a callback function that is going to execute on every element, and it's going to test every element to see whether or not if it is going to be included inside of the new array. So our callback function needs to return a truthy or falsy value. If the result is truthy, then it will be in the new array. If it is falsy, then it won't. So in a way, we are transforming an array itself as opposed to the elements or the values inside of the array like the map method does. So the callback function is very similar to the map method, at least as far as the parameters are concerned. We have the current element that we are working with, followed by the index of the current element, and then the array itself. But most of the time we typically just work with the actual element. In this case, I'm going to call it number, but of course, what you need inside of your own implementations really depends upon your own condition. In this case, since we want only the even numbers, we need to make sure that our return statement is going to return true for only even numbers. And we can do that very easily by using the mod operator. If the remainder of a division by 2 is 0, then it of course is an even number, in which case this would give us an array that contains 2 and 4. So it's a very easy, very straightforward operation to perform. The key thing to remember is that it returns a truthy or falsy value. So you always want to return something, because otherwise it would just return undefined, in which case you will have a resulting array that has nothing inside of it. So let's use filter inside of our application. And I think one of the best things that we could do is to filter out all of the person objects that have an age less of 30. So I don't even remember what we have. We have 3 people, 34, 25, and 53 are the ages. So what we can do inside of the view method, because that is essentially where we're building the people we're using map here. So before we even build the HTML elements that are going to represent the individual people, we would want to filter that out so that only the person that has an age that's greater than 30 is going to be inside of the array that is used for building those persons. So if we open up the browser, let's go to filter.html, and we see that we only have 2 people, Jane Doe and Jim Smith. And since we are incorporating their ages, let's go ahead and include that inside of first name. So we can destructure this further to get the age, and then we can just include that inside of a set of parentheses. And there we go. That way we can see the actual ages of those people, and we can be sure that that's what we are seeing. But of course, if we wanted to reverse this so that we have only the people that are younger than 30, then of course the results that are sent to map is going to be different. We only have 1 person there. So the filter method, or at least the filter operation, because it's not just the filter method on the array, but it's one of those operations that are very common in functional programming. And of course, Ramda has a filter method that you could use if you wanted to take that route. However, for me personally, I tend to opt for more native implementations than anything else, because those are typically going to be faster and more efficient. But regardless of what you use, either the filter method on the array object or Ramda's filter method, or you could write your own function for filtering an array. Regardless of what approach you take, the functionality is extremely useful. In this lesson, we're going to be looking at reduce. Now, if you're just looking at the names, you would think that reduce does what filter does. It takes an array and reduces it into a smaller array. Well, no, not exactly. It reduces an array into a single value. So the first thing that we are going to do is step through what reduce does, and then we will actually write the code that's going to use reduce to, well, reduce. So let's take the filter files and let's rename those to reduce, or at least we're going to copy them and rename the copies to reduce. We of course need to change the reference to reduce.js inside of the HTML. And let's jump right into our code. So let's use our handy dandy numbers array. Once again, 1, 2, 3, 4, 5. And let's say that we want to sum all of these up so that we have a total, which is going to result in 15. So we've all written this code where we have an array. We want to sum up all of the elements inside of it, and we use a for loop to do that. So this is nothing new. So inside of this for loop, we have our total, and we are assigning it a new value where we are taking the current total and adding that to the current number that we are working with, so that at the end we end up with 15. So very simple, but this is essentially what reduce does. It iterates over an array and reduces it down to a single value. And of course that value just really depends upon what you're doing for your loop. So let's write this using reduce, so that we will have a total2 variable. We're going to use our numbers, and we will call reduce. Now we need to pass a callback function, but there are 4 parameters for reduce, not 3. The first is the previous iteration's value. The second is the current value. and then the index and array. So the last three parameters, we know those are the same as in filter and map. This first parameter, previous iterations value. Now this is a little special. This is not the previous element's value. Do not make that mistake. I've made it more than I want to count. So the previous iterations value is, well, it's the previous iterations value. So if we look at our for loop, we have a previous iterations value. Every time we iterate, we have this total. So whenever the loop begins, we have initialized it as 0. And so for the first iteration, we have 0 equals 0 plus 1. That assigns the value of 1 to total, so that in the next iteration, the value of total is now 1. That is the value of the result of the previous iteration. So for all intents and purposes, whenever we use reduce here, this is our total. This previous iteration's value is total. Then we have our current number that we are working with, and we don't need index or array in this case. So our function body is going to look like this, to where we take total and we add it to the number. And that's it. The result is going to be returned, and that returned value is going to be used for the next iteration's total. So it is the same exact functionality that we have with the for loop, except that we get to do it all in one line of code. Now, there is one other special thing about reduce, and that is we can pass a second argument to it, and that is the initial value of our total in this particular example. So just like on line 2, where we initialized total as 0, we can pass 0 as the second argument to reduce. That's going to be used as the initial value for total in the first iteration, and everything is going to work just fine. So let's see how we could use reduce inside of our application. And I think this view function is the perfect place because we are already using filter, we're already using map, and it would be really cool if we could use reduce here, because what are we doing? We are taking our array, we are filtering it, we are mapping it, and then we are appending each element to a single parent element. And I put a little emphasis on single there because reduce reduces an array into a single value. So wouldn't it be cool if we could do something like this, to where we don't have to call for each, we call filter, map, and then reduce. And then this would give us the ability to just return the result of using filter, map, and reduce. Because remember, reduce reduces an array into a single value. That returned value could be the parent element that we have created on line 13, that div element. Okay, so that's great. Now let's talk about the callback function that we need to pass to reduce. Well, we have really two things. We have the previous iterations value. I'm just going to call that previous value. And then we have the current element in the array that we are working with, which we are working with an array of HTML elements. So that would be the child node. So the previous value would essentially be the parent element. Well, let's do this. Let's say that we have a function with parent element as the first parameter, child node as the second. We already have a function with that signature, and it is right here, add. Because remember, we have taken append, which let's go ahead and let's open up our helpers. And if we look at append, we are taking in the child node and the parent element, and we are appending the child node to the parent element, and then we are returning the parent element. So really, append is meeting most of our needs, except the parameter list needs to be flipped so that we have the parent element followed by the child node. That's exactly what we did with this add function, except that in this case, we flipped it and then we passed in the parent element. We don't need to do that now. So by just flipping append, we have exactly what we need to pass to reduce. So we could greatly simplify this. So let's see what the result is in the browser. So let's go to reduce.html. Well, that kind of worked. We at least see that we have some content here, and we have the content that we would expect. We have Jane Doe and Jim Smith. But let's inspect this and let's see what actually occurred, because there's something obviously wrong because, well, it just doesn't look right. So here we have the div element that was created for Jane Doe because it has all of the classes and it has the data index. And then we have Jane Doe. That's perfectly fine. However, we also see that Jim Smith is inside of Jane Doe. And the only way that that could happen is if the first iteration for reduce returned the HTML element for Jane Doe as the parent element. Well, that makes perfect sense because we didn't supply the initial value for the parent element. So now we can save this, we can go back to the browser, and we are going to see that everything is as it should be. We have the div element that contains the other elements for our individual people. So that means inside of our code, we don't really even need to create this L variable. Instead, we could just pass in calling the element function for creating a div. And there we've just simplified our code even more. And if we really wanted to, we wouldn't even have to create this add function. We could just directly pass in the flippening of append. I'm not sure if I like that just from an optics standpoint. I think it might be clearer this way, but who knows? Readability is in the eye of the beholder. But I know that this is much cleaner and much easier to read than what we currently have inside of list.js. So with a little finagling, we could essentially do the same thing inside of here. But let's leave that so that we have something to compare to. We have what we have inside of list.js, which is what we ended with in the previous section. And then what we could have is this inside of reduce. Yes, there might be some functional programming gurus that say that, no, you can't do that. That's not what we do. But also remember, we are in JavaScript. We have the ability to use a variety of language features to get the same job done. So for me, from a personal standpoint, I'm going to use the best tools available. And especially when it comes to working with arrays, that means I'm going to be using the methods provided by the JavaScript language itself. Functional programming with JavaScript is a completely different paradigm than what we are used to, and it requires us to rethink how we approach common problems. It may require us to write some extra code, but there's no denying its expressive nature, and with concepts like composition and currying, we're given some pretty ingenious ways of how to reuse code. Of course, we barely scratched the surface of what's possible and available with functional programming, so if you're intrigued by anything you learned in this course, I encourage you to continue learning about functional programming. It truly is a great way to approach software development. Thank you so much for watching this course. Please feel free to contact me through Twitter or the Tuts Plus forums if you have any questions. From all of us here at Tuts Plus, thank you, and I will see you next time.